right, now we're going to move on to the calculator section of our SAT. Our first problem is pretty basic. It's just solving for x. So we're going to subtract 3 on both sides, divide by 3 on both sides, and our x equals 8. Our second one, we're going to set a proportion, a little more wordy. 2 units of length used in ancient Egypt were cubits and palms. 1 cubit represents 7 palms. So I want to keep that in one fraction. The 1 cubit and the 7 palms. And you can relate this later on, that you have to keep the 2 different labels that are related to each other together. And then if you notice up top, the Great Sphinx statue in Giza is 140 cubits long. So that means I keep the 1 cubit and the 140 cubit on top, and the 7 palms, and what I'm going to try and find in palms on the bottom. That's how you know you set it up correctly. We know that 1 cubit is 7 palms. That's a fraction. But we keep the cubits on top and the palms on the bottom. So 1 over 7 equals 140 over x. And we don't really worry about the labels when we cross multiply. 1 times x is x. 7 times 140 is 980. We can use our calculator, and our x equals 980. Over here, anytime we have a fraction, get rid of it by multiplying by the denominator, as long as you have an equal sign. If you don't have an equal sign, you can't do that. But if you have an equal sign, we just multiply both sides by 5. And the 2n over 5, the 5 cancels. And you're left with 2n. 10 times 5 is 50. We divide by the 2, and we get n is 25. And now I plug it in. Make sure you answer what they're asking. 2 times 25 is 50, minus 1 is 49, so my answer is B. The bottom here, there's only one negative that's unique from the other 4 numbers, or other 3 numbers, I should say. So which of the following is not a solution? Well, negative 4 squared is 16, and the square root of 16 is 4, not negative 4. The others all work. 0 squared, and we take the square root of 0 is 0, and that's 0. 1 squared is 1, the square root of 1 is 1. And 3 squared is 9, and the square root of 9 is 3. They all work out. The negative obviously does not work there. In number 5, whoops, sorry about that. In number 5, we're using the graph here, and even though it's an exponential decay, which represents the curved graph, we do need to recognize the starting point on any graph is always what would represent the y-axis, where 0 is x. Where's that y-axis? And you always have to make sure that the x is 0, because the x is always 0 on the y-axis. And it looks like we're starting somewhere between 180 and 200, so my only answer could be 195. And that's what the temperature is going to be right when we remove from the heat source. In number 6, they're looking for the 10-minute interval where the coffee has the biggest decrease in temperature. And this is real life as well. Right away, once you take something out of the heater, it loses its heat quickest right away, and then it gradually will go down to the room temperature. So in this case, the biggest drop of heat is right here in the first 10 minutes. And then you can see it starts to taper off a little bit. So the answer is A. Number 7 is knowing vertical angles have to be equal, and knowing that triangles always add up to 180. All right, they tell you x is 100, so 120 is 120. 120 plus 60 is 180, and 60s are vertical angles. So therefore, 60 and 40 is 100, and 180 minus 100 is 80. So my answer is 80. But here we need to know vertical angles, and triangles add up to 180 degrees. Here we have another equation of a line which is all over the SAT, and we need to understand starting point and slope whenever we deal with the equation of a line. My starting point here is $3, but that's not what they're looking for. They're looking for what it costs for each additional mile. And I need to recognize each line is worth 1 mile. And I know that 1, 2, 3, 4, 5. So as I go over 1 mile, how much does the price increase? Well, at 0 miles, it's $3. At 1 mile, it's $5. So that's a $2 increase, and therefore my answer is A. For number 9, the key here is understanding what my denominator and what my numerator should be. So when I read that question, and then I'm going to look back at the graph, on Tuesday, a local gas station had 135 customers. Table above summarizes whether or not the customers on Tuesday purchased gasoline, a beverage, both, or neither. Based on the data in the table, what is the probability that a gas station customer, selected at random? So in this case, they just want a gas station customer. They don't give any stipulation to the customer, so there's a total of 135 customers at this gas station. That's the denominator. And they want to know, of that group, how many did not purchase gasoline? Well, if you look at the gasoline not purchased row, we have a total of 50. So it's 50 over 135. And if you look at your answers, you don't need to reduce it. It's just 50 over 135. Number 10, Wellington High School randomly selected freshmen, sophomore, junior, and senior students for a survey about potential changes to next year's schedule. Of the students selected for the survey, 1/4 were freshmen and 1/3 were sophomores. Half the remaining students selected were juniors. There's 336 students selected for the survey. How many were seniors? So make sure you're answering the question of how many seniors there were. That's the key point here. 1/4 of the total were freshmen. So 336 times 1/4, or dividing it by 4, we can do that in our calculator, is 84. 1/3 of that 336 is 112 when we put that in our calculator. So there's a total of 196 freshmen and sophomores, which means out of 336 students, we subtract that 196 out, we're left with 140. And now half were juniors, half were seniors. So there's 70 juniors and therefore 70 seniors. Number 11, very similar to the earlier proportion problem from number 2. We know plant A is 20 centimeters tall and plant B is 12 centimeters tall. So plant A and plant B are related, 20 over 12. Their ratio from plant A to plant B is the same as plant C to plant D. Since I put plant A on top, plant C has to go on top. Since I put plant B on the bottom, plant D has to go on the bottom because order matters with ratio. Plant C is 54, so now we're going to cross multiply. I reduced this fraction first to make my life easier. I reduced it to 5/3. So 5/3 equals 54 over D. We cross multiply, 5D equals 162. And when I divide by 5, I get 32.4 for my D, which is answer for A. For number 12, once again, a proportion comes up. If you notice, 1 kilometer goes with a 0.6214 miles. So it's in the same fraction. I'm also looking to find out how many kilometers is 3.1 miles. So it's important I keep that 3.1 miles on the same level as my miles here. And my kilometers, what I'm looking for is my X up here. When I cross multiply, I get 3.1 equals 0.6214 X. When we divide on both sides, and there's where a calculator is valuable, I get 4.99. If I don't get the exact answer, I just pick the closest one, which is 5. Number 13 is setting up a systems of equations. We have a cargo helicopter that delivers only 100, 120 pound packages. And for each delivery, it must carry at least 10 packages, but they cannot weigh more than 1,100 pounds. What's the maximum number of packages that are 120 pounds that I could carry? Well, in this case, we're just setting up the system. X and Y represent the packages, and since there's a total of 10, and there has to be at least 10, it's X plus Y is greater than 10. But the weight has to be less than 1,100. So it's 100X, which represents the weight of all the packages, and 120Y, which represents the total weight of the Y packages. Okay. Now, I need to get rid of a variable. If I multiply the bottom by negative 100X, I get this equation down here. And I just copy this equation down here. This little negative here, that was a mistake. Don't worry about that. So we have 100X plus 120Y is greater than or equal to 1,100. Negative 100X minus 100Y is less than or equal to negative 100. And then we're left with 20Y is equal to 100. And then Y equals 5. 5 would be the most packages I can have. Don't get too caught up in the inequalities here. It'll work out almost as an equal sign if it's a greater than or less than equal problem. The next one, another equation of a line. We have a company who purchased a machine valued at $120,000. So right away, we need to recognize that's our starting point. So A is no longer an answer. It's got to be B, C, or D, because the value of that vending machine depreciates by the same amount each year. When something depreciates or appreciates at a constant rate, that means it has a constant slope. So each year, it's going to drop the same amount. Well, it dropped in 10 years from 120,000 or 30,000. So it literally dropped $90,000. So if it dropped the same every 10 years, we'd end up with a slope of negative 9,000. And that makes sense. Plug 10 years in here and you'll get 30,000. It should work out for you. Here we're trying to find the equation of a line based on given 2 points. We need a slope and a y-intercept. I find my slope using slope formula. 4 minus 1 over 2 minus 0 equals 3/2. And there's my slope. When I plug my slope in one of my points, and then I solve for b. 3/2 times 2 is 3. We subtract 3 on both sides, and my y-intercept is 1. And y equals 3/2 x plus 1. The next video will cover the next 15 questions. But we will stop here for this video.